this computer. Get my PowerPoint actually running. Oh, oops.
Robert Belushi, are we going
What's
to
up,
take
Lucas?
notes?
Yes, we're going to be taking notes today. So we're going to be taking notes on dilations, and then we're going to do rotations. So starting with dilations, I'll give you a second to get everything out. Get something to write with, something to write on. Hopefully you have all these in the same place. But we're going to look at dilations to start. So to dilate a point by a given factor, all you have to do is multiply the x value and the y value of the point by that factor. So we're going to start with just points, and then we'll look at shapes. When you dilate something, you're going to make it either bigger or smaller. So if it's a shape and you dilate it, then it's going to get either bigger or smaller by whatever the factor is. If you have just a point, then it's going to kind of get further away from the origin. So let's look at dilating point A. So point A is at 2, comma, -2, and we want to dilate it by a factor of 3. So all we're going to do is multiply both the x value and the y value by our factor. In this case, our factor is 3. So we're going to take our x value for our point A, multiply it by 3. And then we're going to take our y value, which is -2, and multiply it by 3. So our new point is going to be 2 times 3, comma, -2 times 3. 2 times 3 is, of course, 6, and -2 times 3 is -6. So what you'll notice when we do this is that the new point, our A prime, is 3 times as far away from the center as we started out, since we dilated it by a factor of 3. Any questions about that before we move on to shapes? Okay. So as with everything else that we've done so far, when we do it with a shape, we're going to be doing the exact same thing. We're just going to look at the endpoints, and then we're going to move each of the endpoints individually. So if we look at point B, it has the coordinates, let's see, -5, 2, 5, 2. Point C has the coordinates -2, 2. And point D has the coordinates -5, 4. So we want to dilate all of these by a factor of 2. So starting with point B, I'll go over point B and point C, and then I'll let you guys try point D. So we're going to start by taking our x value, multiplying it by our factor, which in this case is 2. So we have -5 times 2. That's a times, comma, and then we take our y value, which is 2 times 2, which is equal to -5 times 2 is -10, and 2 times 2 is 4. So our new point, B prime, is going to be at -10, 4. So that's right here. Then if we look at C, we're going to do the same thing. We're going to take our x value, multiply it by our factor, which is still 2. So -2 times 2, comma, we have +2 times 2. So in this case, -2 times 2, -4. 2 times 2, +4. So point, here, I'll label these. B prime is here. This is C prime. So C prime is going to be at -4, 4. So that's right here. All right. Now what I want you guys to do is try to tell me, what is D prime going to be? And Pamela, that is correct. Jennifer, that is correct. Oh, I need to close this parentheses. Let's see, Todd, that's good. Dane is good. Barb, that's good. Give you guys a couple more seconds. I'm worried that a few of you aren't paying attention here. All right. So Once again, we're just going to take our coordinates like the way they are, so -5 and 4, and we're going to multiply both of them by our factor, which is still 2. So we have -5 times 2, comma, 4 times 2. -5 times 2 is -10, and 4 times 2 is +8. So d prime is at the spot -10, comma, 8, which I believe is right here. Now, if we draw out our triangle all the way, you can see that it's the same, or it's a similar triangle. Right? It's still a right triangle with points B, C, and D. But this time it's about 2 times as big, and it's also 2 times as far away from the center. So each of the points individually is 2 times as far, or twice as far away from the center as the original, and the shape itself is about 2 times bigger. Well, exactly 2 times bigger. All right, any questions about that before we move on and try a little bit more of a challenge? Okay, so here we have a square that's EFGH. What we want to do is first dilate the square by a factor of 3. So I'll go ahead and give you the coordinates again. So E, F, G, and H. E is at the point 2, comma 2. F is at 2, comma, -2. G is at -2, comma, -2. And H is at -2, comma, +2. Now, this is the first time we've had a shape that's actually in multiple quadrants at the same time. But you don't have to do anything different for dilations, which is what makes it kind of easy. All you have to do is multiply your points by the same factor. So we're going to do each one of these individually. I'll start with E prime, and then I want you all to try F prime, G prime, and H prime on your own. So for E prime, we're going to take our X value, which is 2, multiply it by our factor, which is 3. Then we're going to take our Y value, which is also 2, and multiply it by our factor, which is still 3. And we get the point E prime is 6, comma 6. So go ahead and try F prime, G prime, and H prime. Dane, that looks good. Pamela, that looks good. Correct, Todd. Also correct, Todd. And also correct. Jennifer, good on all 3. So while you guys are working on that, I'll go ahead and graph E prime, which is going to be right here. That is a strategy that would take a long time, Todd. Especially because the initial part of it is kind of impossible. Barb, that looks good. All right. Let's see. I haven't heard from Asa, Jocelyn, Dane, Jocelyn, Aiden, Benito. Did I hear from Pamela this time? Yes, I did. Never mind. Not Pamela. Brennan, Carter, Phoenix. I think that's everybody. Carter, that's G prime. That one's good. Asa, double check your X. Still waiting on a few. Brennan, don't work on your math space right now. Work on this. Almost Asa, but double check the X again. So for f prime, what we're going to do is we're going to take our initial coordinates, and again, we're just going to multiply them by our factor. So we have 2 for our x times 3, comma, -2 times 3. That's going to give us f prime, which is the point 6, comma, -6. Then for g prime, we have got -2 times 3, comma, -2 times 3, which gives you g prime, which is -6, comma, -6. Thank you, Todd. I appreciate that you're telling me good job for reading. -2 times 3 and 2 times 3 for h, and that gives us h prime, which is -6, comma, 6. So we can graph each of these. F prime is at -6, comma, -6 prime. G prime is at -6, comma, -6. Did I say that was what F prime was? I meant +6, -6. And h prime is at -6, +6. So that would be right here. And if we connect all of these with incredibly straight, beautifully drawn lines, we'll get a giant square that is 3 times as big as our original. Now, new challenge. I want you to dilate the square E prime, F prime, G prime, H prime, which I'll redraw in just a second, by a factor of 1/2. So really quick, I'll put the coordinates back up for E prime, F prime, G prime, and H prime. So E prime was 6, comma 6. F prime was 6, comma -6. G prime was -6, comma -6. And H prime was -6, comma 6.
Wait, would it be E prime prime or just E?
It'd be E prime prime. So you'd use 2 of the prime marks. Or 2 apostrophes. I'll redraw these while you guys take a shot at that. Let's see. Todd, I think those are all good. Yeah. Pamela, those all look good. Dane, those all look good. Brendan, those all look good. How's it going, Riley? Riley, we're working on dilations right now. So you missed a little bit of the notes for them, but we'll have the recording up in just a little bit. I'm also going to post the PowerPoint with this one. So if you do miss any notes, you will have a chance to get them in a little bit. Jennifer, those are good. Barb looks good. I'll give you guys another minute to try this out, and then we're gonna move on. Okay, so I'll go ahead and solve these out so we can move on to rotations. But for rotations, I am not going to let everybody just not participate. So you got to at least try on the next set. But for these, again, we're just going to multiply everything by our factor, which in this case is 1/2. So we have 6 times 1/2, comma, 6 times 1/2, which is just 3, comma, 3. So that would be right here. Then for f, we're going to have 6 times 1/2, comma, negative 6 times 1/2, which gives us 3, comma, negative 3. And then we're going to take g prime, which is negative 6 times 1/2, comma, negative 6 times 1/2, which gives us negative 3, comma, negative 3. And then the last one, we have negative 6 times 1/2, comma, 6 times 1/2, which equals negative 3, comma, positive 3. And if we graph each of these, they're going to be in a similar square, but this time it's going to be just a little bit bigger than the original and half as big as our second square. Okay. So that was dilations. Like I said, dilations aren't too bad, but now we're going to get to rotations. And rotations are significantly more difficult. So everybody needs to make sure you write down the following rules for rotations. So to rotate a point, and again, we're always going to go around the origin, to rotate a point 90 degrees clockwise or 270 degrees counterclockwise, what you're going to do is take your x comma y, you're going to flip x and y, so these two are going to flip, and then the x will become negative. So let's say I had the point 3 comma 4, and I was rotating at 90 degrees clockwise. That would go to, I'd switch these, so now I have 4 and a 3, and then I need to make the x negative, so this one will be negative. The original x, the new y.
Wait, so the way to simplify this for me is I move it to another quadrant, whichever direction it says.
Kind of, but not really. Because you'll notice these numbers switch. So we'll look at it with A in just a little bit. But let's say I did have the point 3 comma 4, and I was going to rotate it 90 degrees clockwise. So it's going to go down to this quadrant down here, because that's where 90 degrees is. But it's going to be at 4 comma negative 3. So instead of just moving it down, it's now a little bit further to the right, and a little bit less far away from the x-axis. So this one is 4 points away from the x-axis. This one is 3 points away, but it's 4 points away from the y-axis. So like I said, it's a little bit more complicated, which is why this rule is very important to get written down. Now, 180 degrees, obviously you can do 180 degrees clockwise or counterclockwise. They're the same because that's half of a circle. So it's going to get you the same point. These ones are the easiest. You just take your x, y, and make both points negative, or take the opposite of both points. So for instance, if I had the point negative 3 comma 2, we're just going to take the opposite of each one. So we'd have the point 3 comma negative 2. So let's see. If we start at 3 or negative 3 comma 2, that would be like right here. If we rotate that 180 degrees, we're going to be at 3 comma negative 2, which is right here. And then the last rule, to go 270 degrees clockwise or 90 degrees counterclockwise, it's going to be, you take your x and your y, you're going to flip them again. So again, you'll switch whatever these numbers are. And now the new x, the original y, is going to become negative. So if I had the point 2 comma 5, and I want to rotate that 270 degrees clockwise or 90 degrees counterclockwise, that's going to go to negative 5. So we flipped these and we made this one negative, comma 2. So again, 2 comma 5, that'd be right here. For rotating it 270 degrees clockwise, which is, or 90 degrees counterclockwise, it's going to go to the point negative 5 comma 2, which is right here. So these are the 3 rules we're going to use for rotations. They're a little bit difficult, so let's get a little bit of practice in. Let's start by rotating point A 90 degrees clockwise. So point A has the coordinates 6 comma 4. And we want to rotate it 90 degrees clockwise. So to do that, we're going to take our original xy, we're going to flip the numbers. So we're going to switch 6 and 4. And then we're going to make the x value, the original x, so the 6 is going to become negative. So that's going to give us the point 4 comma negative 6. 4 negative 6 is right here. So that's going to be a prime. Now I want you guys to try this. Rotate point A 90 degrees counterclockwise. So this time we're going the other way, we're going 90 degrees to the left in kind of a counterclockwise circle. So this time you're going to use this rule down here. And again, the coordinates for this point are 6 comma 4. Correct, Pamela. Good, Jennifer. So you're definitely going to want to have these rules down to reference. Memorizing this is not going to be particularly easy. Todd, you went the wrong direction. You have the right numbers, but you got to flip the sign. Good, Dane. Now you did a 180 degree translation or rotation, Todd. Barb, that's correct. All right, so we're going to switch our numbers again. This says to take our x, y, and make it negative y, comma, x. So we're going to take the y value, which was 4. It's going to be first, but it's going to be negative. So we have negative 4, comma, and then our x, which is 6. So this would be rotating at 90 degrees counterclockwise. Now, I'm also going to do 180 degrees rotation, but I'm not going to make you guys do it. So this is what they would look like. This is our 90 degrees clockwise. It's A prime down here. A prime prime, A double prime, that's our rotation 90 degrees counterclockwise. And then our 180 degree rotation is right here. Now, all of these points kind of might look a little bit weird to you, but we can actually draw a perfect circle through all of them that is centered on the origin. So this is the center of this circle. So you can see the coloring kind of gets more dark as we go into the center. And then you've got a circle that goes perfectly through all of those points. So that's what a rotation is supposed to do. And if we go 90 degrees on this circle, we're going to stop here. Then another 90 degrees that stops here. And then another 90 degrees stops here. And then back to where we started with another 90 degrees. Okay. Any questions about this part of it before we try it with a shape? And then we'll be done for the day. Okay, so on the next slide, If you're not participating, I'm going to assume you don't understand this, and I'm going to make you stay later to get some extra practice. So please pay attention and give this a shot. So what we're going to do is rotate triangle ABC in the following ways. We're going to start with 180 degrees clockwise. So I'll give you the points again. I'm going to write these at the top this time. So A is at the point 3, 4. Oops, now the thing's in my way. Stop, go away. So 3, 4. B is at 3, 2. And C, looks like a parentheses, C is at 6, 2. So we want to rotate these 180 degrees clockwise. And hopefully you have your rules written down, because otherwise this is going to be very difficult. Dane, good. Jennifer, good.
All the points?
Well, yeah, all 3. We're rotating an entire triangle this time. So I'm only gonna actually make you go through 2 of these transformations, and then the last one I'll just go over really quick, so that we can get you out of here close on time. Todd, that is correct for A. Pamela, double check your Y value for your second point. You just change the number, otherwise you're good. Todd, good on all 3. So Jocelyn, did you get your rules written down? Okay, so look at the 180 degrees clockwise. Pamela, that's correct. You fixed it. And what does it tell you to do? Okay, so really quick, I'm going to go back to the rule. So if we go back here, when we're doing a 180 degrees rotation, whether it's clockwise or counterclockwise, we're going to take our x and our y, and we're just going to take the opposite of both values. So opposite of x, comma, opposite of y. So if we go to this one, if we look at point A is 3, 4. So that means that A prime is going to be the opposite of 3, which is -3, and the opposite of 4, which is -4. Good, Aiden. That's good for B prime. And that's good for C prime. We're still missing a lot of people. Brennan, those are good. Yeah, Aiden, I can go back to them after we're done and let you copy them all down. But you definitely want to have these written down. It's going to be really hard if you don't. Good, Jocelyn. Uh, Carter, that's good for B. Jocelyn, that's good for B. All right, I'm gonna use another like 30 seconds to a minute, and then we'll do a 90-degree rotation in one of the directions. So please at least try B really quick if you haven't yet. Carter, that's good for C. And Jocelyn, that's good for C. Okay, so let's look at B. B has the coordinates 3, 2. Again, since a 180 degrees rotation, all we have to do is take the opposite of both of those. So we're going to do -3, -2. It's going to be our new point. And then C, same drill. Take our 6, 2. C prime is going to be the opposite, so -6, -2. Now, if we graph these, A prime is going to be at -3, -4. That's right here. A prime. B prime is going to be at -3, -2. So that's here. And C prime is going to be at -6, -2. So that's right here. So our new triangle is like this. And we can see that it's facing a different direction now. It's in the far or the bottom left coordinate or quadrant, sorry. And if you drew a circle through the or around the center, B's would all hit in a circle, the A's would all hit in a circle, and the C's would all hit in a circle. So with the center of the triangle, so they've all been rotated. So last one, let's look at 270 degrees counterclockwise, which is also the same as 90 degrees clockwise. So if we go back to our rule really quick, so that is this first one right here, 270 degrees counterclockwise. So what we're going to do is we're going to take the original point, whoops, x comma y, and we're going to rewrite it as y comma -x, or the opposite of the x. So again, all of our points are already listed up at the top. I'll go over A really quick because I think this one's a little bit more difficult. So A is 3, 4. We're going to rewrite it as the y value first, so 4. And then we're going to write the negative or the opposite of the x, so -3. So what we're doing is rotating these 90 degrees. So we switch these two, and then we make the y value negative, or take the opposite of the y value. Todd, that's good on all 3. Dane, that's good on all 3. Aiden, that's good on B and C. Jennifer, that's good on B and C. Carter, that's good on B. Jocelyn, that's good on B. Carter, that's good on C. So as you guys are working on that really quick, the homework for today is either the math-based task for rotations on the Cartesian plane, or IXL P13 and P14. And just like we did last time, you can, since there's 2 IXLs, if you choose to do the IXLs, you can just do, you just need to get them to 70 to get a 4. You don't need to get them both to 80. I missed a couple while I was talking, so let's see. Pamela, those are both good. Jocelyn, C, that's good for C. Jocelyn M, you're close, but you need to make your new y values negative, or take the opposite. Aiden, that's good for A. And Jocelyn C, that's good for A. So when you finish all 3 points, which I know a few of you have, you're free to take off. I mean, I guess I already gave you A prime. So when you finish B and C, you're good to take off. Have a good rest of your day. I'll see you tomorrow. If you want more practice with this, please stick around. Barb, you're also good. Yes, Pamela, you're good. Jennifer, you're good. Jocelyn C, you're good. Dane, you're good. I think Aiden was good. Carter, yeah, you're good, Carter. You got them both. Internet kicked you out. Okay. No worries, Jocelyn. It's okay. That one is good, Jocelyn. The second, or the one you just put in for B. Benito, you're close. Just make sure you take the opposite on your new Y values. Brennan, those are all good. Oh, wait. Actually, hold on, Brennan. Your last one is wrong. Double check your C. Jocelyn M, that's good for C. So you're good. Do you have the rules all written down, Jocelyn, before you leave? Okay, then you're good. There you go, Brennan. Now you're good. So I think I saw Benito. Yeah. Yeah, Jocelyn M, you're good to go. Benito, did you get what I meant when I said you just need to take the opposite of your Y value? Oh, yep, you did. There you go. You got it. So you're good. So Phoenix, Riley, and Asa. Are you guys stuck somewhere, or do you need help? I guess I can stop recording at this point.